Hi, these are the Lesson 7.4 notes on rational exponents. Today we'll convert between exponential and radical forms. We'll talk about some shortcuts in working with these rational exponents, problems that have fractions in the exponents, and we'll talk about some shortcuts that you can do when we do division and multiplication problems involving these types of exponents. A couple formulas at the top of the page I want to refer to. We're going to be dealing with these things called exponential form equations, and when you're working with exponential form, we're talking about a problem that has basically a base with this kind of exponent right here. This is what's called exponential form, this first expression right here. Radical form, a radical is basically this symbol. We sometimes think of it as like a root symbol, like a square root, or it can be a cube root. Radical form is this form right here. Now, when we have an expression that's an exponential form, I'm typically going to refer to the numerator as the exponent itself. So this m that's listed right here, I'm going to consider this to be the actual exponent, whereas the denominator of this fraction is going to be considered to be the root. Now, we've heard of roots before. The root is essentially the number that's before this radical sign. So if I write a to the m over n power, the bottom number, kind of like the bottom of a tree is the root, the bottom of our fractional exponent is also the root. So here's a little tree here. The roots are down here. So the roots are always at the bottom of our fraction. And when we write something in radical form, the root kind of goes out in front here. A, and then your exponent is still in the exponent here. If you want to write this with parentheses, you can do that. You can write as the root first and then the exponent second. If you're working with negative exponents, a negative exponent, all that means is that your answer can be written as a fraction. A to the negative m power does not mean that your answer is negative. It means you're going to be working with a reciprocal. A to the negative m power is 1 over a to the positive m power. So a negative exponent basically puts this under 1. It kind of writes it as a reciprocal. So think negative exponents result in reciprocals. For the first set of problems, it says write each expression in radical form. Again, the key thing is to think about the number on the bottom of this exponent is the root. Roots are at the bottom. So when we see x to the 1/4 power, the top number is the exponent, the bottom number is the root. In radical form, the bottom number is the root. So the root is what we write before our radical sign. And then we have x to the 1st power. The root's on the bottom, that's what goes out front here. The exponent stays with the x, so x to the 1st power stays with the x. Same thing for the second example. What's on the bottom? 3. That's your root. So we're taking the 3rd root of x to the 4th power. The top number is the exponent. It stays with the x. It stays in the exponent. Here we have x to the 1.6 power. You might notice that this is not a fraction. It's written as a decimal. So how do you deal with these decimals? Well, as a fraction, if you think of the number 1.6, this is like 16 over 10. We know it's 16 over 10 because the 6 is in the tenths place. And if you do 16 over 10, you move the decimal over. That's kind of what you get here. Now, 16 over 10 can be reduced. It can be reduced down to 8 over 5 because you can divide each of these by 2. And now that you have it as a rational exponent, number on the bottom is the root, followed by the exponent, x to the 8th. So in all these problems, the bottom number goes in front, the exponent stays with the x. What do I want you to do if you see x to the negative 2/5 power? The first thing is negative exponents result in reciprocals. So we're going to write this as a reciprocal. 1 over x to the positive 2/5 power. To keep this in radical form, what we're going to do is we're going to write this as 1 over, the number on the bottom is the root, exponent stays with the x, so it's the 5th root of x squared. Answer, 1 over the 5th root of x squared. When you're asked to write each expression in exponential form, we're kind of reversing the steps here. These are all in radical form. To get it in exponential form, you have to think about what's the root and what's the exponent. In the first problem, it doesn't appear like we have a root or an exponent, but you may remember that a square root means a second root. And if there's no exponent here, you can assume that x is being taken to the 1st power. So when we write this as a rational exponent problem, we have our x. Your exponent stays in the numerator. The root goes in the denominator because the roots are on the bottom. Same idea for this problem. The root is the fourth root. Roots go on the bottom of the fraction. The exponents stay in the numerator, x to the 5/4 power. What do you do in a case like this? Well, there's two things here. There's both a 4 that's getting cube rooted and an x squared that's getting cube rooted. Now, there's no exponent with the 4. Let's change that. Let's actually make that have an exponent. You have an exponent of 1 if you don't see anything with it right now. So we're actually going to take both things and cube root both the 4 to the first and the x squared. So the 4 to the first is going to get cube rooted, so the root goes on the bottom. And the x squared is also getting cube rooted, so that root goes on the bottom of the exponent as well. Both things under the radical sign get rooted. What do you do in a case like this? Square root of 4xy to the fourth. Square root means we're talking about a second root. Now at this point, what we have underneath the radical sign are three different things that are all being taken to the fourth power. The 4 is being taken to the fourth power, the x is going to be taken to the fourth power, and so is that y. So each of these things are going to be square rooted, which means the 2 goes on the bottom of these fractions. Exponent stays with the values. So what we have here is we have 4 to the fourth power, but then that's going to be put with a root of 2. The x to the fourth power will also have that root of 2, and so will that y to the fourth power. Now we could simplify these things down a little bit here. We know that 4 over 2 is equal to 2. So each of these things are basically 4 over 2 is squared. The x is being squared, and the y is being squared. You should know what 4 squared is equal to. That's 16. So your final answer is just going to be 16x squared, y squared. And that's how you convert from our radical form back to our exponential form. In this last set of problems, what you're going to do is you're going to simplify these expressions without using a calculator, using some of the same rules we did before. How do you solve these out here? What does 16 to the 3/4 power mean? I like writing these problems in radical form because I think it makes it a little bit more clear what's going on. 16 to the 3/4 power, the bottom number is the root. So remember, the bottom number is the root. So what we're doing is we're taking the fourth root of 16, and the 16 is being cubed. Now, how do we do this without a calculator? I don't know what 16 cubed is. But you may recall at the top of the page, we can actually, instead of calculating 16 cubed, we can actually do the root of the number first and apply the exponent second. I like that procedure. I like making this value smaller compared to bigger. So instead of doing the fourth root of 16 cubed, let's do the fourth root of 16 and cube it. What's that going to give us? Well, the fourth root of 16 is one of those numbers you're supposed to know. Think of what to the fourth power gives you 16. It's 2. So the fourth root of 16 is 2. 2 times 2 times 2 times 2 is 16. Fourth root of 16 is 2, and we have got to cube it. 2 cubed is something you should know. 2 times 2 times 2 is 8. That should be something that you can handle without using a calculator. Second problem, 8 to the 2/3 power. Again, bottom number is your root. Cube root of 8 squared. Now, you could do maybe the cube root of 8 squared. That's possible. 8 squared is 64. That's kind of nice. But I always like doing the root part first. Let's make our numbers as small as possible. I think that's going to make things easier in the long run. The cube root of 8 is something you should know. Cube root of 8 is 2. So this thing in parentheses is equal to 2. And then I've got that exponent out front. 2 squared is equal to 4. Lickety split, no problem. 100 to the 1/2 power. It's not 50. It's the square root, or the second root of 100 to the first. It's the second root of 100 to the first power. Now here, 100 to the first power is just 100. So this is really just the square root, the second root of 100. That's 10. Piece of cake. Uh-oh, decimals. 4 to the 2.5 power. Okay, again, remember, if you aren't sure what the fraction is, or the equivalent is, 2.5, there's kind of that tenths place, so this is 25 over 10. You can reduce this down. Sure don't want to work with 10th roots or 25th powers. You can divide each of these things by 5. 25 divided by 5 is 5. 10 divided by 5 is 2. So this is really 4 to the 5/2 power. Okay, that doesn't make things a whole lot nicer, but I do know the bottom number is the root. Top number kind of stays with the exponent. I don't know 4 to the 5th power, but I do know the square root of 4. So let's think of this as being the square root of 4 that we're going to take to the 5th power. Square root of 4 is 2, and 2 to the 5th power. I use my hands for this. 2 to the 1st is 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And that's your 2 to the 5th power. Down here, what do you do if you're working with negative exponents? We said negative exponents result in fractions or reciprocals. Negative exponents result in reciprocals. So first of all, let's get this negative exponent out of here. 9 to the negative 1/2 power is 1 over 9 to the 1/2 power. This is 1 over the second root of 9 to the 1st power. 1 over the square root of 9. Well, the square root of 9 is just 3. That's your answer, 1/3. 16 to the negative 3/4 power, same thing. Write as a reciprocal, 1 over 16 to the 3/4 power. The negative goes away when you write it as a reciprocal. Okay, so what's this equal to? Well, we've already done 16 to the 3/4 power. It's 8. If you want to show the work again, you can do that, but it is a problem that we had earlier. It's 1 over the 4th root of 16 cubed, which is 1 over 2 cubed, or 1 over 8. Piece of cake. Negative 8 to the 2/3 power. This problem, the exponent is not negative, so don't do the reciprocals. We're going to be doing the third root of negative 8 squared. Similar to what we did in this earlier problem, if you want to do negative 8 and square it, okay, you can do that. I kind of like doing the cube root part first. The cube root of negative 8, what times what times what gives you negative 8? Negative 2 times negative 2 is 4, times negative 2 is negative 8. So this is negative 2 squared. And negative 2 times negative 2 is positive 4. Last example, 16 to the negative 0.5 power. Write that as a fraction. You know negative 0.5, that's negative 1/2. Bottom number is the root, but there's that negative exponent, so we need to write it as a reciprocal. 1 over 16 to the 1/2 power. That is the same thing as 1 over the second root of 16 to the 1st. Second root's a square root. 16 to the 1st is just 16. And the square root of 16 is 4. Answer, 1/4. So in conclusion, a few things that you should consider as you're working on this assignment for today. First thing, on problems where you're asked to write expressions in radical form, 2 things that you need to make sure you're understanding. Number 1, your answer should have a radical sign. That's that thing that looks like a square root or a cube root or a 5th root symbol. So make sure that they have this symbol on there. Also make sure that you don't write negative exponents in your answer. So if it starts with a negative exponent, make sure your radical form does not have a negative exponent in it. On problems where you're writing expressions in exponential form, make sure that your answer has an exponent in it. It does not have to have a fraction exponent. It doesn't have to be 5 over 4. It could be just like an x squared or a y squared, but make sure there are exponents in your answer. Finally, on expressions that you're asked to not use a calculator with, obviously, if you're doing an assignment at home, I'm not going to be able to see whether or not using a calculator. However, you will not be able to use a calculator on the test on this unit, so by practicing without using a calculator now, it should set you up for success down the road here. Things you should know include powers of 2, 2, 4, 8, 16, 32, powers of 3, 3, 9, 27, 81. All of the roots that we talked about the other day in class, those are things that you should know about as well.